now that we reviewed how to make box and whiskers and histograms and mean, median, mode, and range, we are going to move from simply constructing these data distributions to analyzing them. You're now making the step to not only understand what the data is saying, but analyze it in terms of what it means versus another data distribution. So, today we're going to learn how to compare and contrast two data distributions. Here I have the box and whisker of the height of players in college basketball and the box and whisker of the height of players in the NBA. In order to compare and contrast these distributions and analyze them, the first thing we should do is write down what the box and whisker is telling us. So here, 92, that's the upper extreme, right? So that's the tallest player. These are all in inches, by the way. Now, 92 inches, that is 7'8". A large man. Okay? 65, that is my lower extreme, or the shortest player. This person is 5'5". Easy enough. But what matters more importantly than that is what goes on here in the box. My lower quartile is 73, which is 6'1". Okay? That marks the 25% percentile. Sorry. Anyone in college basketball who is more than 73 inches tall is in the upper 75%. Anyone that is shorter than 73 inches tall is in the lower quarter of players in college basketball. My median, or my average, the center, is 77 inches, which is 6'5". And then my upper quartile is 80 inches, which is 6'8". I'm now going to apply the same details and conclusions to my MBA. Data down here. Now the shortest player is the same, both 5'5". The tallest player, though, is not as tall as in college basketball. The tallest player is 7'6". So one conclusion you can make already is that they have the tallest player, and they being the NCAA. Looking at my box here, the lower quartile is 76 inches, which is 6'4". And like we said, that is my 25% mark. My average is 6'7", and my upper quartile is 6'10", or the 75% mark. While I might not see a huge difference in the extremes, I do see a large difference between the boxes for the NBA and the NCAA. Let's make our first conclusion. Which group of players do you think on average is taller? Well, the median in the NBA is taller than the median in the NCAA. The upper quartile is taller than the upper quartile. The lower quartile is taller than the lower quartile. Which would be 6'1". So we would say on average the NBA is greater or taller than the NCAA. That is a comparison of the centers, the measure of center, and the median or the mean. We understand that the box is shifted to the right on the NBA and shifted to the left on the NCAA. That's why it's nice whenever you're comparing these distributions to draw them on top of each other with a similar number line. That'll help you make the best comparison possible. The data, if we look here at our whiskers for both, relatively similar variability. Your whiskers are roughly the same. The lower whisker is bigger for the NBA, the upper whisker is bigger for the NCAA. But on average, I would say the variability is roughly the same between each. Now, if I had someone in the NBA who was only 52 inches, I would say the NBA has much greater variability. Okay. When we compare distributions, the two things that we focus on are their centers and their variability. We look at the center box, compare that, maybe compare some extremes as well. And then we see the variability based on how spread out the data is. That is why a box and whisker is the most helpful for this type of data in terms of comparison. It's easy to look at the center, it's easy to look at the spread of the data, much more so than in something like a dot plot. You will now be moving to creating your own box and whiskers with your own comparisons. Make sure when you do these comparisons to be very specific. Okay? If the NBA is taller than the NCAA, defend that answer by saying it has a greater median and greater upper quartile along with a greater lower quartile. The NCAA has the tallest player because their upper extreme is greater than the NBA's upper extreme. These are all specific answers that help you become a better statistician and provide better, smarter answers for these problems. Good luck.